code aspect you see here, it fails here. When you enter the first one as a real number, it fails. Okay? Alright, so now go back to the thing. How many such cases you want to handle? You are not sure yet, right? So that's where you go to this idea of equivalence partition. Now to start with, we know that we want to work with positive integers, right? So we can categorize the inputs into two classes, integers and non-integers. Non-integers means real number or anything, right? So anything in this category is unacceptable to us. We want to work only with integers, right? Then within integers, what is really we want? We want positive integers. So anything negative integer is still not going to be acceptable for us. Either first is negative or second is negative or both is negative, we don't want it, right? Then within positive integers, we have three situations. The first is larger than the second, both are the same, and then second is larger than the first. So there are three possibilities, right? Both the integers are positive, and the first is larger than the second, second is larger than the first, and both are equal. So we have 5 possible kinds of inputs. That's what we call 5 kinds of partitions, or different types of test cases. So if I have a representative for each of these partition, representative numbers, okay? So any non-integer for both A and B, or just one for this first or the second or both, will fall in this category, right? Negative will fall in this category. Then the positives. So you have to come up with just 5 test cases. Okay? Everything will fit within this. So how will you test your program from software engineering perspective? Given that original Java code, you have to identify the equivalent partitions like this, and then come up with what is called representative numbers, test cases. So for the first test case, it means only what? It is non-integers, come up with 2 real numbers. You could have just one real number if you want, but it still falls in this category. The second test case is what? Both are positive and the first is greater than the second. So if you notice here, I have 2 more things, oracle and log actual. Oracle means what? Prediction. Okay? So given just a specification, the specification of the program is what? Accept 2 integers, tell whether the first is greater than the second or not, right? Given that, you would expect that the program will catch that the user has not entered integer values. So you would expect the program to throw an error telling enter only positive integers. Okay? But it does throw an error, but it's not really captured as a formal error message. It's like an exception. That's what happened when we run this, right? We got an input mismatch exception. Then when we input 8 and 4, the program was written to handle that, right? We check first is greater than second, it says yes. So the oracle says if you run it actually with these inputs, you will get yes. Okay? And then the third test case is what? The second is greater than the first. So 5 is greater than 3, so you should say no. If you run it, it will say no. That's what the program was written. Now the fourth test case, 4 and 4, they are equal. So remember the code was what? First greater than second. So if 4 is greater than 4, it's no. And you predict it to say no, and the actual output will also be no. And the fifth is what? Both are negative. Both negative is -3 and -8. So how the program is written? The program is written what? First greater than second. So first is -3, -8, which is greater? -3 is greater, so it's going to say what? Yes. So that's what actually will happen, but you would expect the program to say what? An error message telling it only positively, because the program is not supposed to process negative integers. Currently the program is not written to handle the situation. Okay? As well as the first scenario, even though you get an error message, we want a more formal way of that. So let's fix one by one. So we want to fix the program to handle this test case where if the user enters real numbers, it has to be appropriately processed to display the error message, and if the user enters 2 or even 1 negative integer. Okay? So let's do the first one where we will have to catch the exception. So previously the program was not written within a try-catch block, so now I am going to write that into the try-catch block. Why? Because the user may enter a real number for the integer input. So here the exception is thrown here. Or the first number may be okay, the second number may be a real number. So the exception could be thrown here. So once the exception gets thrown, none of this is executed. We have to catch the exception and handle it. Right? So, and of course, in this program, the user enters negatives or real numbers, we have to just give an error message. There's nothing else you have to do. So, put the whole thing in a try block and then catch the exception like this. Catch is a keyword and then input mismatch exception is a class name for a specific exception. Or you can write a whole superclass name exception if you want, but this is more specific for this exception, and say enter only positive integers. So the red thing is what I added to the code, the previous code. Okay? So this can handle test case 1 now. Alright? And now for test case 5, where the user enters what do you call negative integers, okay, that other one is slightly better. You have to handle how? You have to check the value. So how do you check? After getting the two inputs, first and second, check if first is less than 0 or the second is less than 0. So if either way, we have to print an error message telling that the user can only enter positive integers. Then you don't want the rest of the program to be executed. So you can have this return in semicolon. So the return and semicolon will just return from this program to the control will be passed to the operating system. So if the user enters any of this, the first or second as negative, you can just print the error message and basically like exiting or stopping the program. Okay, so return is similar to, you can say system.exit of 0 if you know Java. But this return you can use even C++ the same way. It will stop the rest or execute the rest of the program. Right? So you can play with this. And this is the second part of the quiz. So this is probably more easier than source code analysis. Okay? So, any question on this? I have also some sample questions, the question bank we can go through. So now let's move on to risk analysis. How many are here? 2 people are missing, right? Okay. Now, what is that?
Just software engineering.
You already covered it?
Yeah.
Okay. This will be slightly different. Okay. Alright, so let's start with some terminologies. So what we are trying to do here is, given an application, we want to find out what are the possible risks associated with the application. So we have not yet started coding. Okay? So the customer has come to you and he has told you, I want you to develop a software to do certain things. Okay? So you try to find out from what he wants, the requirements, what are the possible risks or threat, first of all, that will be associated with that application. Okay? So I normally explain this with an example. Okay, so let's say this there's a projector here, right? So this is kind of asset. Asset means something that you want to really protect, valuable thing. Okay, so let's say this door doesn't have a key or a lock; it just closes and someone can open it, right? So that is the vulnerability, which means if there's an asset, if there's no key for the door, all right, so whoever can enter can open the door, come and take a projector if they want, right? So vulnerability is that. So it's a weakness in the system. It could be either in the design or the program implementation, okay, that might be exploited to cause a loss or harm, right? The threat is really what? A set of circumstances that really exploit the vulnerability, right? So the threat is really what? Someone coming, finding out that the door doesn't have the key. Unless they know that, they cannot really exploit that, right? So someone has to know that the door doesn't have a key, then they have to really be able to like know that and then open the door and come and get that, right? So that's the threat. An attack is basically executing the threat. Okay, so the threat is that someone can open the door and come and take it. If you execute it, someone comes and really does that, that's an attack. Okay, so that's the difference between an attack and a threat. So someone knows that there is a vulnerability or one or more vulnerabilities, and you kind of plan for that as a threat and execute the plan. So the planning is the threat part. There's a threat, which means someone can really do all this sequence of things. The executing the threat is an attack. Okay? The risk is what is the kind of possibility that the attack can occur. Which means again with this, what's the possibility that someone can open the door and come and get the projector? Right? If the possibility of that is going to be very minimal, say 0.0001, it's normally expressed in different values, but most of the time it's 0 to 1, like a probability. So it's a probability with which an attack can occur. So the probability is kind of very low. Again, it depends on the context. For certain applications, even this is a very big probability. Okay, but if say this is really a small value, the risk associated with it is very small, then you may just want to leave with it. You don't want to really fix the problem or fix the vulnerability. Okay? Like this case, if it takes it's very expensive to put a lock on this door, and the probability that the risk that someone can really open the door and come and take it is very small, you better leave the door like that. Why you want to fix it? Okay? On the other hand, if the risk is too high, say close to 1, then you better remove the vulnerability so that no one can really launch the attack. Right? So that's the kind of how you decide whether to handle the vulnerability, remove the vulnerability or not. Okay? So that is really the control. The control is what more you do to fix the problem. Okay? So the control is an action or a device or a procedure, the code that you add to mitigate. Mitigate means reduce the impact of the vulnerability. Sometimes you cannot totally avoid the problem, you can just reduce it. Sometimes you can totally remove the vulnerability if you can, right? So that what? The risk could be reduced. Okay, so you can reduce the probability of the attack from happening to insignificant value. Okay. So overall, we can summarize all these things by this line. A threat is blocked by deploying controls for one or more vulnerabilities. So almost all these keywords are covered in this sentence. A threat is blocked by developing controls for one or more vulnerabilities, so that you can reduce the risk. Okay? Clear? Okay, some more terminology. So asset is actually the thing that you want to protect. It could be an object, it could be a data, it could be some information, things like that. Likelihood is what is again the probability that an event will happen. Okay. Sometimes we can express it as a probability, sometimes it's not possible to express it quantitatively, so we can indicate it in a qualitative fashion whether the likelihood of an attack happening is high, medium or low. Okay, so qualitative. Similarly, the impact would be like if the attack happens, what's the impact on the organization, what's the impact on whoever using the software, right? So again, it could be represented quantitative, monetary, okay, reputation of the organization. If say you're using a company software and say your credit card numbers are kind of hacked or whatever, and you no longer want to use the software, right? So the reputation goes down if the attack happens. sometimes the impact may have to be represented in a qualitative fashion, whether it's high, low, or medium impact. Okay? The risk exposure is basically the product of the likelihood and the impact, which means like, given that the likelihood of the risk attack to happen is like this, and the impact if the attack happens is this, what is the kind of, again, the risk is like this. If the product, which means it's not really the product, if considering both the likelihood and impact, okay, we'll go through some models so that will be more clear later, but this is, as I said, it's a measure of the overall impact of the organization. Given that this is the real impact and the likelihood of it, then what is the overall impact on the organization is the risk exposure. Okay? So various factors really contribute to the risk. For example, the ease of executing an attack, the motivation the attacker has, and what resources he has, and the existence of the vulnerabilities, and the impact. Even someone can launch an attack, what's the impact on the organization? So no one wants to take kind of lot of risk, and then if the impact on the organization is very low, they don't want to launch the attack, right? So all these factors determine the risk. Okay? Now, we are going to focus more on the risk assessment model, but in terms of the general overall kind of stages, okay, so I'm going to look at more into all these things, but I'm just highlighting the different stages. We can look at both quantitative as well as qualitative. If you look at quantitative, there are only 5 stages. If you look at more qualitative, there are 2 more stages like this. So let's see what are stages. First, you want to find out about the application. Okay, so as I said, you need to know what is that you want to develop as a software. Okay, so the requirements of the software is normally given to you as a specification, right? So sometimes the application details could also be available in terms of the design document. So if you have gone through and designed the system, then you could have got the design document. So someone has to read all these artifacts, which means all the documentation of the application, to kind of find out what would be the vulnerabilities associated with it. And then what is that you really want to protect? Is it a data or database, or is it just some physical objects like this? What is that you really want to protect? And now, given all these things, you want to kind of assess what will be the vulnerabilities with that kind of software that you are going to develop. The vulnerabilities could be application specific. For example, if you are developing something like what we saw some time back, a file reader program that is run in escalated mode. Remember that talk tower attack and all these things. So you could write a file reader program that could be kind of manipulated to read a password file, even though the user cannot have the permission to read the password file, right? Remember that? The file reader program, which can be run in a privileged mode, right? And you run in the background a symbolic link attack, and you kind of manipulate it so that you can read a password file. So that's an application specific vulnerability, because you are developing a what is that called? SetUID program. You want to develop a SetUID program that you want anyone to be able to run, even though you are trying to read file. Okay. Then platform-specific vulnerabilities. What is platform-specific vulnerability? Familiar thing. If you are going to develop your application in C, it's highly probable that you may have a buffer overflow problem, right? If you are going to develop in, say, Unix, again, it has its own problem. One problem with Unix we saw is what? Symbolic link vulnerabilities. Okay? So different operating systems have different problems. So in general, you can say the platform. Okay? Then vulnerability due to ambiguity. Ambiguity means what? You are not clear on how to develop the program. So one thing that we also discussed in terms of, remember, if a student has logged in to, say, the POS, and then his account is locked, should he be allowed to do whatever he can? And for that session he has logged in, because he has already logged in. So if you lock his account after he has logged in, can he still register or not? Of course, if he logs out and then logs in, he will not be able to register, like a top-down project that you did. Someone has already opened the file pointer, so even though you reset the right permission, you let the user to update that file, right? Isn't it? That's what you did in the project that you submitted today. So that is one way to handle it. Otherwise, every time the user wants to write to the file, check if he has the right permission, which you don't want to do because it's too time consuming. Unix does the first approach. That's what you install on a Ubuntu platform, which is a Unix-based thing. It checks for the right permission only the first time you open the file pointer, the file descriptor, right? Otherwise, you don't let, after that you just you cache whatever you checked and then let the user to update. So you have to be clear on that. There should not be any ambiguity. Okay, so either one way or the other, you should make sure that this is what the way you want. So then the next stage is threat analysis. Threat analysis is, so given that you have identified the vulnerabilities, so each vulnerability could contribute to one or more threats. Okay, so that's where we are going to start from, the threats. And then the next stage is risk analysis. So for each threat, what is the risk that the attack can happen? Okay, remember the attack is when the threat is executed, right? So what is the risk associated with someone executing that threat to launch an attack? And there you can look at two models, a quantitative model, which is like these two models, which we'll see as we go, and then the qualitative model will have three more stages. Okay? So let's start with the first one. This is just a recapitulation on those terminologies which we saw in the first or second module. So for a given asset, we want to always maintain what? Certain properties, right? The CIA properties. Remember the confidentiality, integrity, availability, then authenticity and the non-repudiation, right? So you have to remember all these things. So let's just recapitulate all these things here. Confidentiality means what? You want to maintain the secrecy of the information. You don't want any unauthorized person to learn that information. Integrity means what? You don't want again any unauthorized person to change the information, right? Then information non-repudiation means what? You don't want someone to deny that they did it. So if something was done, we want the system to be able to trace back. Okay, so if someone changed their, say, course, you logged in and dropped a course, then later you cannot say, I did not drop the course. Right? So if you did drop the course, the database administrator should be able to trace back and say you logged in on so and so date and so time using your username and password, and then you did this action of dropping the course. Right? So there should be some traceability back to indicate that you are the one who did it. Okay, so that even if the user denies it, he cannot really prove that he didn't do it. So that is non-repudiation. Authenticity is what? Validating is really that user who's doing all these things. It's like using the password. Remember I saw in the second chapter using passwords or this smart cards or the biometrics to authenticate a user. Okay. Availability is associated with what? Making sure that the resource is available or the system is available for their genuine use. You don't want anyone to launch a denial of service attack and make the system not available for any genuine user. Okay. So these are the desirable properties for any asset you want to protect. And we will analyze this vulnerabilities and the threats, whether they will affect any of this. Right? So the several threat models, the one that we look at with and is more commonly used, called stride threat model. The name comes from the first character of these 6 things. Okay. So all these different threats can be grouped into the 6 categories. Okay. So spoofing identity. Spoofing identity means like you are kind of faking someone else's username, right? So if you happen to know a user's password and of course then the username, then you can log in as that user and do certain things, right? So that's called spoofing the identity. So in general, using someone else's authentication information to illegally obtain access can be grouped under spoofing identity threat. Okay? And actually I show a mapping between each of this with the feature that we want. So spoofing identities associated with what? Authentication. So you're trying to give a false authentication, right? And try to access something. Tampering with data. So that means what? You're really modifying the data. So even a database, the SQL injection attack that we saw, or hacking the network channel and trying to inject some data, or even looking at the data, is associated with tampering attacks, tampering with the data. And that goes with what? Integrity. Because if you change the contents, that's affecting the integrity of the data, right? So let's map to this. Repudiation is really the opposite of non-repudiation. So repudiation means users deny that they did it. Okay? So we want the opposite of property of that they cannot deny. Okay? So that becomes then non-repudiation. Okay? So if you see the mapping here, repudiation is mapped to non-repudiation. And tampering is integrity. Right? And then what? Information disclosure. So which means any threat that leads to information getting disclosed to unauthorized individuals who are not supposed to have access to it is grouped under information disclosure. And this could affect what? The confidentiality of the information. Right? And then denial of service. This is a very common attack where you deny service to valid regular users. Which means, for example, you could make a web server temporarily unavailable to the registered users. That's a denial of service attack. Elevation of privilege is what we have been doing. You let an unprivileged user to gain elevated privileges. Okay, so it's sufficient enough to compromise or destroy the entire system. Okay, and this one affects what? The availability, right? So if someone kind of denial of service affects availability. The elevation of privilege does what? It affects the authorization, which means like an unprivileged user is able to get the access, like the file example, where once you change the write permission, right, you should not be able to write to the file, which means he's not authorized to write to the file, right? But he's able to do that because his privileges are escalated and he can write as a root to that file, right? So that's a top-down attack. So elevation of privilege, you are affecting, is dealing with what? Authorization. Okay? So you should know how to map and kind of explain these different categories under the strike threat model. Okay? So now we are going to really consider some application scenarios, and we are going to really do what's called a threat analysis. Okay? So for each vulnerability, how a threat could evolve. For that, we are going to look at from 2 points of view: the attack patterns, which is like more a verbal description of how would someone launch an attack to exploit that threat. The other is an attack tree. Okay? The attack tree is more graphical way of representing it. So an attack pattern is a blueprint of how one could exploit an attack. So why this is needed? Because I think I've told before. So if you want to be a security professional, you have to think from attacker's point of view, how they would launch the attack, how they would break in. Right? Again, an attacker needs just one way of launching the attack. If he finds like when you do attack path, attack tree, he just needs to figure out one way to penetrate the system. Whereas a security professional should think all those ways and then block, have controls through which you cannot, the attacker cannot enter any of those ways, right? So that's why it's very important to really think from an attacker's point of view and see what are the possible ways someone could launch an attack, and then you deploy controls on all those ways. Okay? So let's see an example. The decompression bomb, actually if you go to the site, they have some more examples of writing attack patterns. Again, as I said, an attack pattern is a formal documentation that a software engineer has to develop when he's kind of developing this application, so it has to have all these components. Okay? So the pattern or the kind of attack or threat we are going to see is denial of service, and the application or the kind of problem is what's called decompression bomb, which means when you open a zip file, right? Let's say you are trying to load a zip file to a web browser, right? It has to be uncompressed, right? So when it is uncompressed, you have to watch out how many bytes you are really uncompressing. For example, if the compressed file is only 10 kilobytes long, if the uncompressed file is 1 gigabyte or 1 terabyte long, there's some problem associated with it, right? You have to watch out for it, because when you uncompress this, you get so many bytes, you have to store all these things in memory, then you will run out of memory very soon. Right? So if you are running an application where it tries to uncompress whatever the document and then store it in memory and process it, if you don't really monitor how much you are really uncompressing, then you will soon run out of memory. Right? So that is this problem. It's called a decompression bomb, because if the developer didn't kind of monitor how much the application is really decompressing or uncompressing, whatever you want to call, then the resources will be quickly exploited. Okay? So that is the actual description of the attack. Okay? What is the prerequisite for the attack? The attack must, this cannot be launched everywhere, right? This can be launched only in applications that decompress a compressed data. Right? You cannot launch this application in any web browser. You can launch this only in web browsers that decompress the compressed data. And the decompression should be automatic. You should not prompt the user to whether he wants to decompress or not. If he decides not to decompress, then your attack will not be successful, right? So the decompression should be done automatically by the software, right? So it could be done normally in a web browser or kind of HTTP protocol, or even email. So if an email gets loaded up and it had a compressed file as attachment, if you want it to be automatically decompressed,